This is going over the periodicity test and Group 2, Group 7. I'm going to have a look at probably question 1, first page to begin with, and I'll see how much I can get into the short video, then I'll go on to the next pages. Okay, with question 1 it says the elements in period 2 show periodic trends. Identify the period 2 element from carbon to fluorine that has the largest atomic radius and explain your answer. So between carbon and fluorine, you have a look on the periodic table, because we know that going across a period from left to right, the atomic radius decreases. So looking at the choice from here, you're going to put in carbon. The reason that that is the case is that in carbon there are less protons, so smaller nuclear charge and less attraction from protons to external electrons. It's also to be noted that in period 2 the shielding remains the same. So in this one there's 3 marks for the question. The first mark comes from the carbon. The second mark comes from the fact that you realise that as you go from carbon to fluorine there's actually more protons. So out of this, with the largest atomic radius is the one with the least protons, because it has a smaller nuclear charge, it'll attract the electrons less, making it the largest atomic radius. And bear in mind that going across the period you're going to have more, the shielding remains the same, so they're looking for 1 mark for the attraction, and particularly between the protons to the electrons, and the shielding obviously remaining the same. It then goes on to say, state the general trend in first ionization energies from carbon to neon. So we're looking at first ionization energies. Deduce the element that deviates from this trend and explain why this element deviates from the trend. So the general trend across a period, like we have in period 3, would be an increase, a general increase. However, the element that deviates from that is oxygen. And the reason for oxygen deviating is its outer electrons are paired in a 2p orbital. Make sure you don't write shell here, it's actually the orbital. Often we draw the orbital with the little square blocks. So what we're finding with oxygen is it has its outer electrons in a 2p orbital that actually have to occupy the same orbital, and it's the repulsion between the electrons in the same orbital that reduce the first ionization energy. Okay, 4 mark question for this, so obviously there'll be 1 mark for your increased trend, 1 mark for saying that oxygen deviates from the trend, 1 mark for realizing that you have a pair of electrons in the 2p orbital, so they want the 2 orbital, and obviously that's a representation there with them both in there. And then the third, that's the 3rd mark, and then the 4th mark is the repulsion between these electrons, which are in the same orbital, reduces the first ionization energy. Then says, write an equation including state symbols for the reaction occurs when the first ionization energy of carbon, so it has to be carbon, is measured. So you need carbon as an atom, because it's the first ionization energy. You'll be removing the first electron to form a 1+ carbon gas ion plus an electron. You don't need to write the state symbols on an electron, but you should definitely write them here and here, otherwise you're going to lose the mark. And it says then, explain the second ionization energy of carbon is higher than the first ionization energy of carbon. This is because there is going to be more energy required to remove an electron from a positive ion. And you'll get that full mark for that, just saying that you're going to actually try and remove an electron from an already positive ion. So that's the end of page 1, and we'll do another recording going on to page 2. Then it says, deduce the element in period 2 from lithium to neon that has the highest second ionization energy. So we're having a look at lithium. Now I might use the space just here just to go through why.